Okay, so now we're looking at the second part of the COLA problem. And instead of having the actual mean be 299, we're looking at it as 295. So much of the problem is exactly the same. I still have my null and alternate with the 300. Mu is less than 300 as our alternative. Standard deviation, 1.225 staying the same. I have the 0.2037 up here in the corner just to remind us what our value of power was when the actual value was 299. The curve is going to start off the same. We still think the average is 300 in the middle to start with. The 297.985 is the same. Okay, so we're still doing that with the inverse norm. The 0.05 is still, let me put that on there, 0.05 is our alpha starting point. Okay, so all that's the same. But now we have to do with what the actual average is. So now we're seeing, okay, if it's 295 milliliters instead of the 300, what's the chance that we're going to reject? So we're going farther away from the average. 299 was 1 milliliter away. 295 is 5 milliliters away. And actually think about how this would shift, how much it would shift. We're at 297. Our center is actually going to be on the complete opposite side of our value that's going to be the reject value. So if I was to draw this curve, I'm going to try and make it as nice as possible here to show this. And I did a pretty horrible job of it. We're going to pretend that 295 is in the center. But what I want you to see here, what I need you to understand is that now that 297, the 300 is still all the way over here. The 297.985 is now on the right-hand side. This is still our beta that we're going to be looking for. Okay, our alpha, it's out the window now. Now that we know that the 300 is not true, we're assuming 295 is the actual value. That alpha doesn't matter anymore. We still know it's on the left-hand side, but now we can calculate beta. Okay, and now we have to use a normal CDF to calculate that beta over here. So if I'm doing normal CDF, okay, I'm using the same exact problem. That pink line is my lowest boundary. So 297.985. We still have an obnoxiously big number. Now our average is the 295. And 1.225 is our standard deviation. So that normal CDF problem here should give you 0.0074. And that is our beta value. So that is the value to the right of the reject area, which in this case is to the right of the average here. So it's a much smaller value. So we calculate our power, 1 minus 0.0074. That ends up giving us a 0.9926. So 99.26%. That's saying that if we are 5 milliliters below 300, if the actual average of our sample is 295, that's going to give us a 99% chance of rejecting, knowing that the average there, 300, is incorrect. So the chance of us getting the correct answer, rejecting when the null is false, is going to be a 99% chance if we're 5 milliliters away. If we were only 1 milliliter away, they're closer together. So that chance of getting, if they're that close together, it's harder to see the difference. It's not a big difference. It's very small. It's not significant. There's only a 20% chance of us getting the correct answer and indicating the correct answer that we should reject when it is false. When they're farther away, since there's a big difference, a significant difference, there's a 99.26% chance. Okay? So the farther the actual average is to what we think it is going to give us a higher power. Okay. So try and rewatch these videos, understand them, give the water temperature problem a chance yourself, and in the next video will show how I did that calculation.